All right, hello there. Today we are going to go over lesson 4, and today's lesson is super fun. I think you're going to enjoy it, and I think it's going to be fairly straightforward for you because it's a review of the number line. So you know that it's going to be awesome. First of all, I wanted to show you this tweet that was out there. Did it bother anybody else that the guy from that Operation game was clearly wide awake? Oh my gosh, look at him. It's totally true. I feel like I should have noticed this as an anesthesiologist, but alas, I did not. But now I know because of that tweet, and it is kind of disturbing. Now that I see that, I don't know if I can play that game again. We're going to have to put tape over his eyes and make him look like he's asleep. Anyway, let's jump into mental math, and we're going to look at some cute slots and other fun things while we do this. All right, let's see if you can remember what a score is. I know you know what it is. It's like 20, right? So what would 5 score be? Let's see if you can figure that out. Okay, how about B? Let's see if you can do this one in your head. 10 dozen. Don't worry if you're doing this a little slowly. You'll get the job done. It's all good. How about C? You can look at that cute giraffe while you're doing it. What is half of 500? All right, D. Let's see if you can do this one in your head. 350 plus 400. What is the answer? E, how about 50 times 50? Be careful on this one. Sometimes all those zeros can be tricky. Remember, it's 5 times 10 times 5 times 10. I don't know if that helps. Let me know. If not, you can just look at a cute polar bear. They're vicious in real life. Don't think that they're cute. Okay, the last one of the mental math. What is 400 divided by 10? Okay, and G. And the reason why I put some grass here is to help you out with this problem, because you're going to start with the number of feet in a yard. And I don't know if you remember this from last year, or maybe it was the year before that when I taught feet and yards and all that stuff. But my little visual mnemonic for this is to actually picture feet like somebody standing in a yard, right? And so here's their foot. Except for it's not 1 foot in a yard, it's 3 feet in a yard. So you have to picture 3 feet. And the thing that makes it disturbing and also memorable is that there's 3 feet. Why would there be 3 feet and not a different number? I don't know. Maybe this is like some weird 3-legged sheep or something. I don't know. I just came up with that. And he's happy. And he has a cat ear. And anyway, it's a weird 3-legged. It's just supposed to help you remember that there are 1, 2, 3 feet in a yard. And get it, a yard like a backyard or a front yard. Here's the grass. So there you go, 3 feet in a yard. Now you're never going to forget that, right? All right, so start with the number of feet in a yard. Multiply by 12. Divide by 6. Add 4. Double that number. Add 5. Double that number. And then double that number. What is the answer? If you are like me, you are really confused by all that and you feel like this about now. It's okay. You can skip back or you can read it. Take your time. Last time you got all of these correctly, this mental math and the problem solving. I was super impressed. I mean, not even a single mistake. It was amazing. Let's jump into the problem solving. Okay, here we go. So Simon could see. Simon sees. Anyway. Okay, Simon held a dot cube. And a dot cube is just the way that they say dice, whatever. And he could see 7 dots. So what that means is he could see 3 of the faces, kind of like this, as if the dice was like this. It's facing him. So he can see 3 faces, right? But it says that he can see 7 dots. Here we're seeing more than 7 because there's 4 and there's 7 right there. But in his dot cube or in his dice, whatever, he's holding it in a way that he could see 7 dots. How many dots could he not see All right, let's see if you can figure that out. I will let you pause it. And I'm going to move on to the new concept. And Murray seems really excited about that. It's a smashing idea. You're going to love this. I love Murray. He's like one of my favorite. Well, you know, he's one of my favorite characters. All right, here we go. The new concept is the idea of the number line. And a number line is just, it looks like this. It helps us arrange numbers so that they make sense. They're in some sort of order. The 0 point of the number line right here where it says 0, that has a name. It's called the origin. Okay, so the origin is the 0 point. Anything to the right is a positive number, and it doesn't matter if it's barely to the right, like it might be right there, or infinitesimally small, little smidge to the right, whatever, it's positive. It's if it's to the right of the origin. Likewise, anything to the left of the origin is going to be a negative number. Anything negative is less than 0. Okay, makes sense. So far, so good. These little lines have a name, and they're actually called tick marks, and those show the integers. So I just said a new vocabulary word. I know you know what this is, but I'm just going to define it real quick, just to refresh your memory. Integers include all counting numbers. Okay, so you remember what counting numbers are. Counting numbers are the same as natural numbers. Those are the ones you say when you naturally count something. You start with the number 1, say 1, 2, 3, 4, 5, 6, 7, etc., all the way to infinity. Those are counting numbers. So an integer includes all of those, but it also includes their opposites. So if I say the number 1, the opposite is -1. And then also, it includes the number 0. So basically, an integer would be everything that you would put on a number line, and that's why they introduced that vocabulary word right now. Okay, so those are integers. Easy peasy, right? So far, so good. The other things to point out on a number line is the ellipses. You remember that word. Basically the ... when you're writing something like this, -1, I'm going backwards. So if I write something like this and do -1, 0, 1, ... So these ellipses mean that the negative and positive numbers are infinite. So these arrows at the end of the number line mean that it's infinite. What else? Let's see. Okay, the next paragraph, so if you're following along on page 22, it basically points out that the more to the left you go on the number line, the less the number is. And so that's kind of confusing sometimes because -6 is less of a number than -1. You have less stuff if you have -6 of it. Is kind of like digging a deeper hole, like in debt or something like that. So even though the absolute value of that number might be bigger, if it has a negative sign in front of it, or if it's to the left on the number line, that means it is less than anything on the right. And speaking of that, they're going to next ask us to compare two numbers. So when we compare two numbers and you decide which one's greater or which one's less than, you can think of the number line to help you figure that out. So for example, -5, and this circle means you're going to put in if it's less than. And remember, less than looks like that, and it kind of looks like a sideways L. And this is greater than. And this one kind of looks like a G, like you can turn it into a G. Or you can think of it as the alligator and is eating the bigger number, whatever. Anyway, so let's go over these examples. What about -5 and 4? So 4 is to the right on the number line, so this is going to be the bigger number. So we would put that there. An equation means that the two sides are equal, and it doesn't matter how you write it. 3 plus 2 is the same as 5. So if you were to put 3 plus 2 on a number line, you would put it in the exact same place as 5. Okay, easy peasy. What about this one? If you are comparing 5 and -6, which number is bigger? Well, you have to decide which one is more to the right on the number line. Since this is a positive number, I'd rather have $5 than -6, so I'm going to choose that one. That one's greater. Okay, easy peasy. Let's do an example. Arrange these numbers least to greatest. Snap, snap, I know. I wanted this to be a quick lesson. Now I feel like it's getting long because I ramble too much. So snap, snap, I'm going to get to it. Here's the thing about example 1. They want you to put these numbers in order from least to greatest. However, they're putting if you look at just the absolute values of the numbers like 0, 1, and 2, I feel like they're trying to trick us because this could, someone that's not as smart as you might say, oh, well, it's a 0 and a 1 and a 2. I'm going to put them in order. But that's not how it goes because this is a negative number. So to arrange the numbers in order, you're going to put them in the order that you would see them on a number line. And if you draw a number line, obviously, you're going to start with -2 and then 0 and then 1. So that's the order that you would do it. Okay, so this is the answer. Bam. Maybe I'll put some commas in between, but there you go. All right, example 2. Here's another Murray. That makes me laugh. Look at him. Oh my goodness. All right, example 2 is compare these two numbers basically. So we have a -5 and we have a +3. You know this. Which amount of dollars would you rather have? -$5? That means you owe someone money. No way. Let's go with $3. I'll take $3. And it also wants you to use words to write the comparison. And so if I were to use words here, I would say -5. I guess that's not a word. That's a number. So I'm going to write -5 is less. Excuse my bad handwriting here because I'm trying to be quick. Is less than 3. You get the idea. Okay, you would write it the same way you would say this expression. And I would say -5 is less than 3. All right, you can also use a number line to add and subtract. And example 3 is going to show us how to do that. So they want us to show this addition problem on a number line. And the addition problem is a super easy one, just to make the point, and it's 3 plus 2 equals, well, it just gives you that. Okay, so let's go up from 0. We're going to start at the origin, always start at 0. And then we're going to draw an arrow 3 units long. So 1, 2, 3. It will straighten it out for me. So that is 3. Now it wants us to do the rest of the equation, which is +2. So it's kind of like what I did at the origin, but now this is my new origin, is 3 over. And now I'm going to go 2 over from there. So 2 over from there makes you end up at 5. I didn't draw it very good, but there's another 2. So you have 3 plus 2 is equal to 5. Okay, that's easy, super easy way to do it on the number line, but let's go into example 4, and it's going to be a little bit more intense, just like that little GIF there, which is show this subtraction problem on a number line. So subtraction is just a little bit trickier. Here's what we're going to do. We are going to start at 0 again. So start at 0. And the first number is basically a +5. So I want to go 5 to the right. 1, 2, 3, 4, 5. Boom. There. And so that is 5. Now I'm at 5. Okay, easy peasy. Now the next number is basically -3 because we're subtracting 3, right? So let's change the color. Let's go 1, 2, 3. Boom. Okay. So -3. Or 3 to the left. Sorry, I don't want to do like a double negative, so I'm just going to do 3 to the left. So 5 to the right, 3 to the left. That's what you're doing. Where do you end up? Well, we end up right here at 2. Of course, it's easy with small numbers, but once you get to more complicated numbers, you're going to see that that totally makes sense, and that might help you with some of the more complicated problems. So it's just, we're just learning the concept here, right? Hello, you're still with me? It's okay. All right, let's do example 5. Example 5 is show this subtraction problem on a number line. Now this one is definitely more intense because it's 3 minus 5. But if we do it the same way, we'll end up with the right answer. We start at 0. Go up from there. The first number is a positive 3, so we're going to go 3 to the right. 1, 2, 3. Bam. Okay, we're here. Now I'm going to go up from there. Now the next number is basically a negative 5, so I'm going to go 5 to the left. 1, 2, 3, 4, 5. We kind of need graph paper for this, right? So this is 3, this was 5. Okay, so where do we end up? We end up at negative 2. Boom. 3 minus 5 is negative 2. Okay, easy peasy. Now, don't forget, remember that subtraction is not commutative. So what I mean by that is when you do 5 minus 3, you're going to get the answer 2. But as you just saw from the previous examples, if you do 3 minus 5, the answer is actually negative 2. So that is a totally different number. In fact, what do you notice about those? They're opposites. So it turns out that when you switch these, you get the opposite number. Kind of think of the opposite as the upside down. I don't know. Does that help? Anyway, yeah. Let's do the next part. So reversing the order gives you the opposite, kind of like Murray and Urey. No, I don't know. But that's a funny little picture. Let's do example 6. This one's going to be a little interesting because it has bigger numbers in it, right? So example 6 is to simplify. Whenever they say simplify, that means solve it. And Squidward's going to help us out because it's opposite day. So if you look at these numbers, you're like, how am I going to subtract that? Because I'm clearly going to end up with a negative number. So how do we do a problem like this? It turns out that it's going to be easy peasy because what we're going to do is we're going to switch the order. If we switch the order and then do the subtraction, the answer you get is going to be the opposite, just like Squidward is pointing out. It's going to be the opposite of the actual answer. So let's switch them and see what we get. All right, so let's start with here. 0 minus 6. Oh, can't do that. We got to borrow. So let's make that a 3. Turn that into a 10. Now we have 10 minus 6. 10 minus 6 is 4. Now let's do the tens place. 3 minus 7. Uh-oh, have to borrow again. So let's take something from that 8, make it a 3, or make it a 7, and turn that into a 13. Now we have 13 minus 7. 13 minus 7 is 6. Okay. And then we're going to subtract the hundreds. 7 minus 3. 7 minus 3 is 4. Now, remember that we switched the original problem. So the answer to the original problem is going to be the opposite of this. The opposite of this is negative 464. And that is your final answer. All right, easy peasy. You are done with this lesson for the day. So have fun doing your homework. Love you, Addie. Have a great day. Bye.